Hello and welcome to MyScience Tutorials. In today's video, we are going to be looking at the concept of logic and mathematical processes. Before we begin, if you are new to MyScience Tutorials, kindly consider subscribing and pressing that notification button so that you don't miss any of our latest tutorials on biology, chemistry, mathematics, and physics. So let's begin. So we are looking at the concept of logic and mathematical processes. Before we begin, let's have a look at what is called a statement or what a statement is. A statement is a declarative sentence, the word declarative sentence, that is either true or false but not both. So whenever we have a statement can either be true or false but not both. So a statement cannot be true and then false at the same time. It can only be one of the above, that is either true or false at a time. Now, every statement has a truth value, namely true. So a statement can either be true, which is denoted by T, or false, which is denoted by F. So that is the truth value of a statement. So it means a statement at a particular point in time can either be true, which we denote by capital T, or false, which we denote by what? Capital F. The possible truth values of a statement are often given in a table called the truth table. Now, we will be looking at what truth table is in the next example. But before we go there, let's look at how we can identify statements if we are given examples of sentences. Alright, so example number 1. Which of the following are statements? And for those that are, indicate their truth value. So A, root 2 is an integer. Now, is this a statement or not? Yes, root 2 is an integer because the answer to this question is either true or false. So root 2 we know is an integer. So in this case, it is a statement. And is this statement true or false? It is true because root 2 is an integer. Now B, why should I study mathematics? Now this is a question. The answer to this question can never be what? True or false. So if you are being asked why should I study mathematics, then you would have to give an answer to this question by probably stating the reason why you don't want to study mathematics. Maybe you are so scared of mathematics, or maybe you think it's difficult, meanwhile it is not, or any other answer you have for the reason why you think you should not study mathematics. So this is not a statement. Now let's look at C. Monkeys can fly. Is this a statement? Yes, this is a statement because monkeys can fly can either be what? True or false. So first of all, we have it as a statement. Now, is it true that monkeys can fly? Whoever says monkeys can fly, well, that person is deceiving us. Science has not taught us that monkeys can fly. So this statement is a false statement. D, please keep quiet. Now this is a command, or you are being told to keep quiet. You cannot say the answer to this question is true or false. So this is not a statement. Now E, John is a boy. Is John a boy? Yes. So this statement, or this final example, John is a boy, is a statement. And is it true or false that John is a boy? It is true. So it means it is a statement and it is true. So far, out of the 5 examples that we have, we saw that the root 2 is an integer, is a statement, and it is a true statement. We also saw that monkeys can fly is a statement, but a false statement. We also see that John is a boy is a statement, and it is a true statement. We notice that why should I study mathematics, which is a question, is not a statement because we cannot say the answer to this question is either true or false. Okay, we also saw that keep quiet is not a statement. So let's continue. So we want to look at the negation of a statement, or how we negate a statement. Now, given that a statement P, or we have a statement P, the negation of a statement P is what? Not P, and it is denoted by the symbol, this curve sign, and then a P. So what we mean by this is, when we have a statement P, if we negate the statement, we add not to that statement, and it becomes the negation of the statement, or the original statement. Sorry. So let's have a look at this. Let's look at the statement P, its truth value, and then the negation of that truth value. Now, Amma is a boy is our first statement. Now we know that Amma is a boy can never be a true statement, because Amma is a girl. So the truth value of the statement P that we have over here is false, as we can see over here. But once we negate this statement, a truth statement or a true statement becomes false once it is negated, and then a false statement becomes true if it is negated. In this case, we have a false statement, so once we negate it, it becomes a true statement. Kofi is a dog. Is Kofi a dog? No. So it means the true value of this statement is false. But once we negate the false statement, it becomes a true statement, or a true statement. So it means the negation of P for this example is telling us that Kofi is a dog, meanwhile Kofi is not a dog. Now, Johnson is a boy. Is Johnson a boy? Yes, Johnson is a boy. So this is a true statement. But the negation of this statement becomes what? A false statement. Now, let's consider the statement below. P is the statement that we have, and it states the integer 3 is an odd number. Now, this is a statement, and it is a true statement because the integer 3 is an odd number. But what if we negate this statement? How do we write the negation of the statement P? That is the negation of P. How do we write these statements? Now, there are several ways of writing the negation of a statement. I have listed here some few examples. So the first way you can say the negation of the statement P is, it is not the case that the integer 3 is odd. Or you can say the integer 3 is not odd. Or you can say the integer 3 is even. All these statements mean the same thing, and they all contradict what the original statement P is saying. And because they do, we say they are the negation of the original statement P. Let's continue. Now we want to look at logical connectives. The first one we want to look at is conjunction. So what is conjunction? Now let's have a look at this statement. Given that two statements P and Q, the conjunction of these two statements is the statement P and Q. So it means the conjunction of two statements can be written as P and Q, and it is denoted by the symbol or the phrase P and Q. So it means the symbol inverted V, or this that we have here, is what? The conjunction symbol, and it means what? And A and D. So it means either A and B or B and C. So it is connecting two variables or statements together. So it means and. Let's have a look at an example. Example number 1. We have P, that is the original statement or the first statement. The integer 3 is odd. Then Q, 7 is greater than 5. Now these are our two statements. Now if we are being asked to write the conjunction between these two statements, that is P and Q, how do we write this? So our P and Q is just combining these two statements to form a new statement. That is, the integer 3 is odd, which is this statement that we have over here, or the statement P, and then we use the connective conjunction connective, that is the end. Okay, so let me erase that so that we can see what we are doing. All right, so I said the integer 3 is odd is the statement, or the first statement P, and then the second statement is what? 7 is greater than 5. So this is Q. So do we see that the only thing connecting the statement P and Q is the connective in the middle over here, end, and that end is what we are calling the conjunction. So the statement P and Q is the integer 3 is odd and 7 is greater than 5. Now let's look at the remarks of this conjunction. The truth table for P and Q is described below. Now when we have a statement P and Q, the truth values of this statement are, now P can be true, Q can be true, P can be true, and then Q can be false. P can be false, then Q can be true, and then P can be true, and then Q can be false. Sorry, this is false, false. Okay, so when we want to write the truth table for two statements, we write true, true for the first statement, true, true, false, false, and then the second statement we write what? True, false, just to match it. Now the conjunction between these two statements is what we are having over here. So for a true statement, if P is true and then Q is true, the conjunction between these two statements is also true. So it means this is true, this is true. So true and true is true. Now for the conjunction, or for the connective conjunction, the two statements has to be true for the conjunction to be true. I repeat, for conjunction, the two statement has to be true for the conjunction between the two statements to be true, or the truth table for the conjunction to be true. Once one of them is false or both are false, the statement is false. So if P is a true statement and then Q is false, you cannot say true and false are the same. They are never the same. So if we have true statement and then a false statement, the conjunction between these two statements gives a false answer. So if we have false and true, because one of them is false and we are using the connectives conjunction, it is a false statement. And then once we have false, false, we have a false statement. So let's note the conjunction for, or the truth table for the conjunction. So for the conjunction P and Q, the first statement is true, that is if both are true, and then the rest are false. So let's note this very well. The only way a statement can be true in a conjunction is if the two statements are both true. Let's go ahead. We want to look at disjunction. Now disjunction is just the opposite of conjunction. So given that two statements P and Q, the disjunction between these two statements is the statement P or Q, and it is denoted by the statement P inverted V and Q. So we say, or we call this P or Q. Let's have a look at the example that we used earlier on. The integer 3 is odd as a P statement, and then the Q statement 7 is greater than 5. So the disjunction between these two statements is just combining the two without any connective. So we can say the integer 3 is odd, comma 7 is greater than 5. So this is the disjunction between these two statements. Now let's look at the remark. Now let's look at the truth table for the disjunction P or Q. Now for disjunction, either both statements can be true to make the truth table true, or one of the statements has to be true. So whether both are true or one is true, the disjunction between the two statements is true. But once both are false, the truth table is false. So if P is true and then Q is true, we have a true statement. If P is true and then Q is false, because we are using disjunction, that is true and then the statement or false, once one of them is true, the final truth table, we have what's true as our answer. We have P to be false over here and then Q to be true. Because Q is true, it makes this also true. But once P and then Q are both false, our truth table is false. So for disjunction, the only way we have a false statement in the truth table is when both parties or both statements are false. So it means when both the truth values of the two statements are true, we have a true statement. When one of them is true, we have true statements. And then when both are false, we have a false statement. Let's continue. Implication as the next connective. Now, given that two statements P and Q, the implication of these two statements is the statement if P, then Q. I take it again. The implication of these two statements is the statement if P, then Q. And it is denoted with this. So we have P implies Q. Now, P is called the hypothesis and then Q is called the conclusion. Now, let's have a look at something. This statement P implies Q can be said in many ways. We can say this to be what? If P, then Q. We can also say P implies Q as this same statement. We can say Q if P. It still means implication. We can say P only if Q. It also means implication. Now we can say P is sufficient for Q, or Q is necessary for P. These statements, or all of these statements, are just referring to the statement or the implication between the statements P and Q. Now let's look at the truth table of these statements. So if we have P and Q and then we are having implication between them, let's look at what the truth values of the truth table are. Now when P is Q, it implies Q is also true. So true is true. We have true over here. But now if our hypothesis is true but then our conclusion is false, it means we are having what? A false statement. Okay, so if the hypothesis, which is the P, is true but then the conclusion does not tally with the hypothesis, then we are having a false statement. Now if the hypothesis is false and then the conclusion is true, we have a true statement. That is, false implies true. Okay, and we have a true statement. This is the truth table for P implies Q. Now if we have both to be false, P implies Q, false implies false, that is a true statement. So for implication, the only way an implication will be false, or the truth table for an implication will be false, is when the statement or the first statement called the hypothesis is true but the conclusion is false. That is the only time we get a false statement. Aside that, then we have true statements all along. Let's continue. Let's have a look at an example of everything that we've done so far. Okay, so example number 1. Suppose your teacher makes the following promises, and the promise is if you meet the assignment deadline, then you will get a bonus. Under what circumstance are you justified to say that your teacher spoke falsely? Alright, let's go and dive in. So first of all, let's break down this example that we have. So solution. Alright, so we have the teacher saying if you meet the assignment deadline. Now this is one statement. If you meet the assignment deadline, this is a statement. Then you will get a bonus is also another statement. So let P be the first statement or the hypothesis. That is, if you meet the assignment deadline, and then Q to be the second statement, that is, then you will get a bonus. All right, now we have our hypothesis, this to be our hypothesis, and this is our conclusion. Now, because we know if is starting, we know this is an implication, so it implies that P, if and only if Q, or P implies Q. So from the look at the question, we know this is an implication. So they say, under what circumstance are you justified to say your teacher spoke falsely? So it means we are trying to say P implies Q. That is, P is true if and only if Q is also true. So let's write the implication table for the two statements P and Q. So let's draw our table, our truth table. Okay, so we have the statement P, we have the statement Q, then we have P implies Q. Okay, so when filling the statements P, we have true, true, then false, false. For Q, we tend to balance it with this, so we write true, false, false. Now, I said earlier on, the only way in an implication that you have the truth table for implication false is when you have the hypothesis to be true and then the conclusion to be false. So true implies true, that is a true statement. True and false, we are dealing with implication. True cannot imply false, so we are saying this is a false statement. False implies true, this is a true statement. And then false implies false is also a true statement. So from the truth table, the only way the teacher who spoke falsely is when you meet the assignment deadline, but then he decided not to give you the bonus. Okay, because from the truth table, this is the only way the teacher will refuse or the teacher will speak falsely. So let's answer the question now. Under what circumstance are you justified to say the teacher spoke falsely? So under the circumstance, this is the circumstance that you can say the teacher spoke falsely. That is, if P is true. So if P is true, we maintain it. That is, if you meet or you met, if you met the assignment deadline, that is, you are able to submit the assignment before the deadline. If you met the assignment deadline, but you did not get a bonus or the bonus. So the only way you can say your teacher spoke falsely is if you meet the assignment deadline or you met the assignment deadline, but your teacher decides not to give you a bonus. That will be a cheat on you because you did well to submit before the deadline. So thank you so much for watching.